Okay, hopefully you're beginning to feel you've got the hang of this implicit differentiation. So now I need an equation of a normal. Well, a normal is a straight line, and I need for a straight line a point and a gradient. And I've got a point, so I need a gradient. And of course, the gradient is dy by dx. So that's why I have to differentiate. And we know how to differentiate stuff like this now. We differentiate everything with respect to x. So my first term is my x cubed, so I differentiate that, 3x squared. My next term is a product, so I've got a 4x squared times a y. So I've got a u, which is 4x squared. I've got a y, which is my v. So I do my u dashed, which is 4x squared differentiates to 8x. Y, this v, differentiates to 1, but I want v dashed, which means v by dx. So y, I need to multiply by y by dx to make the derivative come out correct with respect to the correct variable. So I've got the elements of my product, so I need a u dashed v, so I need a plus 8x times y, plus a uv dashed, which is a 4x squared times dy by dx. Okay, so what's that one times that? And then I need to differentiate the y cubed. Well, that differentiates to 3y squared. Oh, but it's y's, not x's, so I need a dy by dx. And then on the other side, I need to differentiate my 6, which differentiates to 0. So this is a y squared dy by dx. Hope that's clear. Well, what we're going to do now is find the dy by dx. As with the last example, I could actually be cheeky and substitute x and y as 1 straight away. But again, I'm going to actually show you how we would find dy by dx in terms of x and y if we had to. So I'm going to have all the dy by dx stuff on this side and everything else on this side. So 3x squared I'm going to take away. 8xy I'm going to take away. And these other terms do have dy by dx in them, and they have one with a 4x squared on it and one with a plus 3y squared on it. Okay, but at any stage I can put in x is 1 and y is 1. I'm going to do that now actually. X is 1 and y is 1. If I wanted dy by dx as a fraction, I'd divide this algebra by this algebra, but I'm going to put my values in. So dy by dx times, well, 4x squared is just 4 because x is 1, plus 3y squared is just plus 3 because y is 1, equals minus 3x squared is just 3 times 1 squared, which is minus 3, minus 8y, which is minus 8, that should have been 8xy, shouldn't it? But it's not going to make a difference here because x times y is still 1. So it's minus 8, which is minus 11. So dy by dx is minus 11 divided by 7. And I want the normal. Now dy by dx gives me the gradient of the tangent. So I do my normal thing, it's a straight line. So I set up my point, and I set up my normal gradient. So point, what's my point? Oh, it's just 1, 1. What's my normal gradient? Well, my gradient of the curve is minus 11 over 7. But that's the gradient of the tangent, isn't it? The gradient of the curve is the same as the gradient of the tangent. The gradient of the normal is the negative reciprocal of that, so I need 7 over 11. Turn it upside down and make it negative. So I've got a point and I've got a gradient, so now I can say that y minus y naught, which is the 1, equals 7/11 of x minus this one. And that's my equation, but I've got to give it in the form ax plus by plus c equals 0. So get rid of fractions, multiply by the 11. So 11y minus 11 equals 7 times the bracket, but that's 7x minus 7. So putting it in this form, I've got 7x, taking terms on this side, minus 11y, okay, minus this 7, but plus this 11, plus 4. And that equals 0. So there is my equation of my normal, and that is, oh, I did it here, yeah? Okay, so from there I got to this. So that was all fun and very pleasant, and yeah, hopefully it made sense.